we're going to be dealing with infinite geometric series, those that go on forever and ever and ever, and we are told that the sum of all the infinite terms is equal to the first term divided by 1 minus r, provided the absolute value of r is less than 1. Another way of wording this absolute value is saying that r is between -1 and +1. Okay, for example, let's say we have the series 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 plus ... forever. If we were to think of this in terms of money, we're starting with $1, adding 50 cents, we're up to $1.50. Add a quarter, we're up to $1.75. This would be 12.5 cents. We'd be up to $1.87.5, etc. What would this add up to if we kept on adding and adding and adding forever? This formula tells us that when the ratio is between -1 and +1, and it is in this case, the ratio is 1/2, that we can find the sum of these infinite geometric terms by going a1 over 1 minus r. Our a1 is 1 divided by 1 minus 1/2. This becomes 1 over 1/2, which equals 2. This means that the sum of this infinite series is 2. You may argue that, hey, I'm still adding things up forever and ever and ever here. It's never going to equal the 2. Well, in the limit sense, if you take all those little tiny fractions way out there, yes, they will add up to 2. And that will be kind of a key topic that you'll get into when you get into your calculus class. Now notice we had said that the ratio needs to be between -1 and +1. I want to show you what happens when the ratio is 1. In other words, all the terms in the series are the same, and 2 plus 2 plus 2 plus 2 goes up and never will add up to a finite sum. It will have no infinite sum. And in this case, we say that the series diverges. When you do have a sum of the series, as we did up above when we found 2, then we say that the series converges, converges to a limit. For these next couple of problems, we are being asked to find the sum of the geometric series if possible. So first off, we need to figure out what is the value of r. We can see very easily that r is equal to 1/6 in this pattern, and since r is between -1 and +1, that means we can proceed. So we actually use our formula now. S sub infinity is equal to a1 over 1 minus r. Our first term is 1 again, divided by 1 minus 1/6. This is 1 divided by 5/6, which then is equal to 6/5. That is the sum of that infinite geometric series. Now, in this next problem, the ratio to go from term to term to term is 6. Okay? This is not between -1 and +1. Therefore, the sum does not or doesn't exist. Sometimes we use the abbreviation DNE for does not exist. Write this repeating decimal as a fraction. Okay, we see that the bar is only over the 8, so let's split this up. We have 0.7 plus 0.008. Let's make that only 1 0 in there. Now plus 0.008 plus 0.0008 plus, I think you see the pattern there. What do we have? This first term is 7/10 plus this series where the first term, 0.08 of the series, would be a1, and the ratio to go from term to term is going to be 0.1 because that 8 keeps moving one place to the right as we go. So let's work on finding the sum of this series with all the 8s in it, and then we'll add the 7/10 on later. Using our infinite sum formula, we will have that a1 over 1 minus r is equal to 0.08 divided by 1 minus 0.1. This becomes 0.08 over 0.9, and I will write that as 90 so that you can see that this basically is equal to 8/90. Now we can reduce that, but I'm going to choose not to because we still need to get this 7/10 involved. 0.78 with a repeater over that 8 is equal to 7/10 plus 8/90. We need to find a common denominator, which will be 90, and that's why I didn't reduce that a moment ago. So we are going to have not 7 anymore, we are going to have 63 over 90 plus 8 over 90 is equal to 71 over 90 as the fractional form of that repeating decimal.